So this is our CA2 review. What I'm going to do here, guys, is go through a couple of questions in each section and get them set up for you. The way you will get the answer is to take the work I provide for you and complete it, which means you'll just need to use your calculator to find the final solution. So let's begin here with Pythagorean theorem. The first section is, do the following lengths form a right triangle? So this is, again, looking at the calculator, and we want a true or false answer from the calculator. On each of these guys, you want to start with your formula. A squared plus b squared equals c squared. Remember that c is always the longest side on the triangle. So when you're given all three sides, you have to make sure that the longest or the largest number ends up in place of c. A and b can switch places. So now I'm going to just come to my calculator here, guys, and I'm going to put this in exactly how I've written it. I'm going to put in 6 squared plus 8 squared equals, is right below the control sign, 9 squared. And when I hit enter, it tells me false. So that means this one is not a right triangle. It does not mean it's not a triangle. It just means that this angle right here is not 90 degrees. That's all that this part of the Pythagorean theorem means. Okay? You will do the same thing on 2, 3, and 4. 5 and 6 are even easier. They tell you A, B, and C. So this is just a matter of using your equation. 6.4 is A, so we got to do 6.4 squared. 12 is B, so we got to do 12 squared. C is 12.2, so we got to do 12.2 squared. Again, calculator, 6.4 squared plus 12 squared equals 12.2 squared, and I hit enter. And again, false means those three sides would not make a right triangle. You can do number 6 yourself. Now, 7 through 12 are all done the same way. We are finding the missing length. So on all of these, we are solving for side C. Okay? Each one, you need to do the same steps. Write your formula. This gets very repetitive, guys, but the more you do the correct steps, the more you write it down, the better you're going to be at it. We're going to replace A and B with 4 and 8. So it means 4 squared. Don't forget the exponent. 8 squared equals c squared. Now, on this step here, you can do both of these on the calculator at the same time. 4 squared plus 8 squared. The whole left side of my equation now is 80. And that equals c squared. We want to know what is side C. So to solve for that, we've got to take the square root of both sides now. So I do control x squared to get my radical. The square root of 80 is 8.944. 2, and we'll leave off that 7. If I'm going to round it to the nearest tenth, this 4 means I'm going to round it to 8.9. The 4 will not let us round up to the next digit. If this second decimal place was a 5, 6, 7, 8, or 9, that would round up 1, meaning the 9 would increase this in whole number to 9. Instead of 8.9, we'd round it up to 9.0. Okay? 8, 9, 10, 11, and 12 are done in this same format. These are A and B, A and B, A and B, A and B, A and B. You're solving for C. Don't forget the square root at the end. When we get to the back side, guys, I want you to just do 15, 16, 17, and 18, 21, and 22. Because on these, we are solving for a leg. Now, what will make these, I think, easier is to call the missing side, side A. As we set this up, it'll look much clearer once we look at it. We're solving for side A, so that means we need to know the Pythagorean theorem in order to find the missing side length on any triangle. We don't know A. Side B is 3.6 squared. Side C then is 7.4 squared. So now I've got to do this on the calculator in a couple of steps. So I've got to come here to 3.6 squared and hit enter. We get 12.96. Then I do 7.4 squared and hit enter. I get 54.76. Now, guys, this is the reason why we want to let A be the side we're solving for, because this looks like an equation. We're going to do our inverse operation to move 12.96 to the other side of our equation. So I'm going to go 54.76 minus 12.96, and the difference of those two is 41.8. And just like on the previous page, our last step is going to be to take the square root of both sides. So when we take the square root of 41.8, we get 6.46. Now that 6 means I need to round my decimal place up 1. So 6.4 is going to round to 6.5. Okay, when we round, we always look 1 decimal place to the right. So if we're going to the tenths place, we're going to look at the hundredths place. If we're rounding to the hundredths place, we're going to look to the thousandths. On this page here, the distance formula. The distance formula is just a squared plus b squared equals c squared. Okay? We have 2 points on our coordinate plane. If they are connected by a line, I cannot count diagonally across the coordinate plane. So that means I'm going to use the lines that make up the grid in the background to make 2 sides to my triangle. I go down vertically and I go across horizontally, connecting those two with a 90-degree angle. Then I just count 1, 2, 3, 4, 5, 6, 7 squares. That's how long that side of the triangle is. That's why we follow the grid. I count 1, 2, 3, 4, 5, 6 squares. That's how long that side of my triangle is. These are A and B. That right angle tells us I am solving for C. Okay? On the distance formula, you always solve for C. So I'm going to write down my Pythagorean theorem. A squared plus b squared equals c squared. A is 6. B is 7. We're solving for side C. Don't forget your exponents. 6 squared is 36. 7 squared is 49. We can add those two together and we get 85 is equal to c squared. Now it's okay if you put this in the calculator, 6 squared plus 7 squared. All that does is skip this step right here where I squared 6 and I squared 7 and then I added them together. That saves you 1 step. It will save you just a few seconds on the test. Take the square root of both sides. When we take the square root of 85, that's not a perfect square. It's not a square that we should know. I'm going to take the square root of 85 and I'm going to get 9.2 is side C. Okay? You're going to do that on the rest of these guys. Now, 4 and 5. Notice the line is vertical. It doesn't go diagonally. So I can just count 1, 2, 3, 4, 5, 6. So the answer here is 6. You won't see a question like that on the test most likely because it's too easy. But anytime the line goes along the grid, vertically or, like number 5, horizontally, 1, 2, 3, 4. 4 is your answer there. Just count how many squares are on the grid. Now, skip numbers 7, 8, 9, 10, 11, and 12. We don't do questions like those. We're going to move on to the back page. It's more of the same. Number 13, 1, 2, 3, 4, 5. That's it. But these that are diagonal, use the coordinate grid to draw your triangle. And then you count 1 square and 2 squares. One is side A, 2 is side B. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. I add those together and I get 5. And then I've got to take the square root of 5, which is, oops, it helps if you type in the 5. 2.23, so that rounds to just 2.2. You'll do the same on 15, 16, 17, and 18. Skip 19 through 26. Okay? We do not need to worry about those. Now, let's talk about transformations. This is the part that we've struggled on the most, so we need to pay careful attention to the details here. The first part is going to be graph the image. Okay? Now, I'm going to do one of them. Actually, I'm going to do two of these. The other two I'm going to let you do. So number one says rotate 90 degrees counterclockwise. So a clock rotates this way. So counterclockwise is this way. So what I'm going to do is simply, I've got my 3 points, J, L, and Z. I want to know what are the primes for each of those. So I'm going to place my finger on the origin, and I'm going to turn my paper 90 degrees counterclockwise. Okay, it's the opposite direction a clock rotates. Now, when I am looking at the graph this way, I'm pretending like it is drawn this way. Okay, not that I have my paper sideways, but that this is the origin. Now, when I find the coordinates for these points, J prime is going to be at +2, -1, 2, 3, 4. Okay, that's the point for this part of it. Is we want to just rotate the paper. We're going to look at it as if it has been rotated, and then we're going to find our coordinates. This is at +3, 0. So L prime is +3, 0. And then Z prime is at 0, -1, 2, 3, 4. Doing this, guys, I will now graph this shape. Now, when I have rotated it, the shape should be now in quadrant 4 instead of quadrant 3. So when I'm drawing it, it should be right here. So I'm going to do J prime at +2, -4. L prime at 3 and 0. Z prime is 0, -4. And then I connect those dots. So I know it's not a perfect drawing, but as we can see, Z prime is on the axis, J prime is on the bottom line of the grid, L prime is on the axis, Z prime is on the axis, J prime is on the bottom of the grid, L prime is on the axis. Okay? That is a rotation. The translations, every point in the triangle, every point in this quadrilateral are going to translate the number of units in the direction that they tell you. Okay? So you are going to make these small translations, draw them on the graph yourself. If you need help, come ask myself or Mr. Caribou. When we reflect across the x-axis, this is the x-axis here. We want to pay careful note of that. When I flip across it, that means points are going to be on the opposite side of it. So watch what I do. Point J, I go up 1. When I reflect it, I'm going to go the opposite, which is down 1. Point C, I come over here to 3. Instead of going up 1, I'm going to go down 1. That's J prime, C prime. K, I'm going to go to the right 1, and then I'm going down 4. So now I'm going to go up 1, 2, 3, 4. And then M prime, I go to the left 1, 2, 3, 4, down 2. Instead, I'm going to go up 2. So what that has done, it has flipped the shape over. The points are now on opposite sides. Every point is the same distance from the x-axis. That's the key to a reflection. Everything moves the same distance from the axis. Now, write a rule to describe each transformation. If we look at 5, this just has been slid over. Okay? So the x-coordinate is our left to right movement. We moved to the right 1 time. The y-coordinate represents our up and down movement. Well, we didn't move up or down. We just moved to the right. So the algebraic rule is that. That's our translation. We've just slid 1 space to the right. Skip number 6. This is a reflection, but it's a reflection over this line here. We don't do that, guys. We only reflect over the x-axis or the y-axis. So what you're looking for is a shape that has been flipped. Left and right side have switched, top or bottom have switched. So let's look at number 7. This is a reflection, okay? Every point is the same distance from the axis. So this is a reflection over the x-axis. So the rule, if you remember, guys, is the x-coordinate stays the same, but the y-coordinate changes, okay? And then here, this is a rotation. Now this one is 180 degrees. It has gone 2 quadrants, either direction. So this is a rotate 180 degrees. So the algebraic representation for that is simply that we change the coordinates on both x and y. Okay? We're going to skip number 10. Let's do number 9. Now, we want to rotate this shape, but the first thing we want to do is graph the points. So I'm going to go -2, 0. I'm going to go -4, +3. I'm going to go -3, +4. And then I'm going to go -1, 4. Now, when I rotate this 90 degrees clockwise, that's going to go from here to here. Notice how the shape is going to turn. Okay? So I want to just turn my paper, and then I'm going to write the coordinates for each of these points from once it's been turned. Okay? So when I rotate my paper, point B now is at 0, +2. Point C is at +3, +4. Point Z is at +4, +3. And then point X prime is at +4, +1. So to figure out the algebraic rule, I want to look at what changed. And I'm just going to pick one point. It doesn't matter which point. Let's pick something like point X and X prime. So notice X and Y changed places. X was a 1, Y was a 4, and they switched. So that means Y is going to be labeled first. X is going to come second. Now, the -1 was our X coordinate. It becomes a positive coordinate when it became Y. So that means the number that is in the X location, when it moved to the Y location, it changed signs. Y stayed the same. It went from a +4 to a +4. That's all there is to it. You put a minus sign in front of the coordinate that changed signs. Okay? When we rotate, every 90 degrees, X and Y switch. So 180 degrees, X and Y stay the same, but they both change. 90 degrees, X and Y switch, X changes. That means at 270, X and Y switch, but Y changes. Okay? So, find the coordinates of each figure after the given transformation. Now, we're not going to do a reflection across that line. 180 degrees, we did this already. That means -x, -y. So that means when we do the rotation, X and Y both change signs. So E prime becomes -2, +2. J prime becomes -1, -2. R prime becomes -3, -3. S prime becomes -5, -2. They both just change signs. Now, a translation. 7 units to the right means X plus 7. 1 unit down means Y minus 1. So for each of these points, I am going to add 7. So -3 plus 7 becomes a +4. Down 1, 1 minus 1 becomes 0. F prime, -2 plus 7 becomes a +5. 3 minus 1 becomes 2. N prime, Negative 2 plus 7 becomes 5. 0 minus 1 becomes negative 1. 6 units to the right, that's x plus 6. 3 units down, y minus 3. Okay, that's all it is to translation. We're adding and subtracting. So, s prime, negative 3 plus 6 becomes positive 3. 3 minus 3 becomes 0. C prime, negative 1 plus 6 becomes 5. 4 minus 3 becomes 1. W prime, negative 2 plus 6 becomes 4. Negative 1 minus 3 becomes negative 4. Okay, the last section here is dilations. On dilations, guys, we are multiplying. So dilations mean we are going to multiply by a scale factor. All that means is you multiply every number times your scale factor. So if we are, whether it's a fraction, whether it's a decimal, whether it's a percent, doesn't matter. So negative 1 times 4.5 becomes negative 4.5. 0 times 4.5 is 0. M prime, negative 1 times 4.5, negative 4.5. 1 times 4.5 is 4.5. B prime, 1 times 4.5, 0. Okay, that one's pretty easy, so let's do one more. Here, x prime, our scale factor is 0.25. So that means I'm going to do 2 times 0.25. That gives me 0.5. So my x-coordinate is now 0.5. Negative 1 times 0.25 means my x-coordinate is negative 0.25. Okay? G prime, 4, 4. 4 times 0.25 means it's going to become 1 and 1. W prime, 1, negative 0.25. Okay? Kind of ran out of room there, but all we do is we multiply of, that means multiply x and y, each number times your scale factor. If they ask us to graph it, negative 1, 1, 1, 3, 0, negative 2. My dilation of 1.5 means it's going to be 1.5 times bigger. So when I multiply, j prime becomes 1.5, I'm sorry, negative 1.5, negative 1.5. U prime becomes 1.5, and then 3 times 1.5 is 4.5. And then W prime becomes 0, and then negative 2 times 1.5 is negative 3. So all I did was multiply each coordinate times my scale factor. Of means times. So now, negative 1.5, negative 1.5. I graphed this wrong the first time, guys, and my apologies. So negative 1, negative 1. Okay? Should be right there. So now we're at negative 1.5, negative 1.5. Negative 1.5, 1, 2, 3, 4.5. That's wrong. 1.5, 4.5. Those are both positive. And then 0, negative 3. So when we graph these here, it's just a bigger triangle. I know that's a little messy. I apologize. So of 1.5, multiply each of these times 1.5. Multiply each of these times 1.5, and then graph it. Okay? Make sure you work on these. Ask questions if you have them.